Hi, I will prove to you now that if I have four lines like this, and I have that these lines are cut by a line like this, and the length of these segments are here A, B, and C, I will show that there's a certain ratio, certain quantity between A, B, and C that no matter which line had cut through here, be it this one, be it this one. In fact, there's special cases, where the line is actually parallel to one of those, and be it like this, or even like this, or like that, that ratio remains the same. But I would just show it for these, starting from this point. Okay. So how are we going to prove this? We extend this line right here, and now we're going to make a line parallel to this one. Notice that these two lines, they meet up here. Alright, now this segment right here, I will call X. This segment right here, I will call Y. Okay. So let me see. This X. This is Y. And I'll name one more segment here. Call this segment right here. Let's call it L. Alright. So now, note that X over Y is the same thing as X over L times L over Y, just by algebra. But now, who's X over L? Notice that since these two lines are parallel, then it turns out that this angle and this angle are the same. Also, since this is also transversal to the parallel lines, right? This angle and that angle are the same. So these two triangles, this big one right here, and then this little one, are similar triangles. So then X is to L as A plus B plus C. This whole segment right here is to the small segment right here, which is C. And now, by a similar theorem of lines crossing between parallel lines, then these two parallel lines, and look at this, then these two triangles right here are also congruent. And this little triangle right here and this one. So L is to Y as B is to A. Okay. Now it is this ratio right here that I claim is preserved. In other words, had I taken a different line here, the A, the B, and the C would have been different. Maybe we could call them capital A, capital B, and capital C. but the x and y would have been the same. So then you would have that this ratio of capital A plus capital B plus capital C over capital C plus times capital B over capital A is actually equal to the lowercase ratio, because the x and the y would still be the same. See, this segment may be different, but then the x and the y here would have been the same. So no matter what line I pick here, the ratio turns out to be the same.